This video is going to be about conjugate acids and bases. So this is review from first year chemistry, maybe, hopefully. All right, so types of acids and bases. We have the Arrenius acid and base, and we have the Bronsted-Lowry acid and base. So the Arrenius definition was come up with before Bronsted-Lowry, and their understanding of acids and bases was simpler. So an Arrenius produces protons, H+. Remember, hydrogen has 1 proton and 1 electron. So if it loses that electron, then it's just a proton. And so it produces H+ when it's put into a water-based solution. And bases produce hydroxide when put in an aqueous solution. So an acid would be something like HCl. If that is aqueous, then it is really H+ and Cl-, so it produces H+. And then a base is something like sodium hydroxide. It has hydroxide in it. When it's put in water, it becomes sodium ions and hydroxide ions. Both of these are 100% soluble. This is a strong acid, that's a strong base. All right, Bronsted-Lowry definition is a little bit different. So if I have an acid like, let's say HCl, okay, and I put it in water, so water becomes part of this reaction, right? Then I would end up getting H3O+ and Cl-. This is essentially, right here, the same reaction as this. All right. Remember, this is a liquid. This is aqueous because it dissolves 100%, and this is aqueous, and this is aqueous. Actually, all acids are aqueous. All right, so it donates an H. So if we look here at hydrochloric acid donated an H to water, and it became hydronium. That's the hydronium ion. Okay, and was left Cl-. So HCl donates an H, so that makes it an acid. And water here gained an H, so, right? So it's the base. All right, and same thing if we were to write like NH3 and water. Okay, NH3 can act as a base. It becomes NH4. So it took H from water, and water becomes OH-. If we look at this reaction, NH3 is a base because it takes one of these H's from the water. So water becomes the acid because it donates the H, and we end up with hydroxide and NH4. What I want you to remember overall is that if it is a Bronsted-Lowry acid, it has to be an Arrhenius acid too. If it's an acid, it's an acid. The only thing that this did was it opened up things like NH3 to be a base. Even though really if this is put in water, it's going to produce hydroxide, it just opened up the definition a little bit more. Okay. All right, so if we look further at Bronsted-Lowry acids and bases, we use these more than we use anything else. All right, so you should be able to think about Bronsted-Lowry acids and bases instead of Arrhenius. All right, these types of acids and bases have conjugate acid and base pairs. Okay, and conjugate acids behave as an acid in the reverse reaction. So if we look at this reaction down here, this is just a fake acid, HA. If we look at it, and we're going in reverse, so we're going to go backwards in this reaction, then H3O+ donates an H to A-. This right here, this H comes over here to H, and this becomes the acid in the forward direction. So the conjugate acid is always going to be the base plus an H. And the conjugate base is always going to be the acid minus an H. So it's what the acid becomes. It becomes a conjugate base. The base becomes a conjugate acid. All right. And it's a little confusing, but it's really easy once you do a few problems. All right. So this is the same that I wrote on the first page. So in this right here, this would be the acid because over here, it's lost an H. So this is its conjugate base. All right. And if this is the acid, because that's hydrochloric acid, this is the base. And this is the base's conjugate acid. So H2O as a base becomes H3O plus, and that's its conjugate acid. And then HCl as an acid becomes chloride, and that's a conjugate base. Pretty terrible conjugate base, but it's a conjugate base. All right? Okay, so we're going to identify the Bronsted-Lowry acid in the reaction above. So this reaction is a little bit strange, but you can see here what we've done is we've got these two things are basically squished together. All right, and so we would end, this is really a salt and chloride. So if I rewrite this like that, then that means that HCl is the acid. Because it's HCl, guys, it's going to be the acid no matter what. It's hydrochloric acid. That's the name of it. And then we want to see which conjugate acid-base pair is not correctly matched. So if this is the acid, that is the correct base, right? So the acid, when we look at it to become the conjugate base, then we have to take away a hydrogen, because that's what acids do. They lose hydrogen. Okay, so that means that the conjugate base here is going to be OH. So this is correct. So HClO4, if we take an H off, we get ClO4 negative. So that's correct. If we have H3PO4, we're going to take an H off, so that gives you H2PO4 1 negative. This has lost 3. So it's not correct. So this is the answer. All right, give the conjugate base for the following acids. So if we're going to take an H off of this one, it's going to be HSO4 negative. If we're going to take an H off this one, it's going to be SO42 negative, right? Because it's losing a positive, so that 1 negative charge right here becomes 2 negatives. Okay, and this one's positively charged, and we're going to lose an H plus, so that becomes NH3. Here we're going to lose an H, so it becomes C2H3O2 negative. And here we're going to lose an H, so it becomes OH negative. All right, and then the opposite is true when we're looking at conjugate acids. So if you have a base, what do bases do? They take H's, right? Okay, because bases gain H plus. And don't forget you're adding the charge to it too. All right, so if we have SO42 negative and you add an H plus to it, you're going to get HSO4 negative. So if you have HSO4 negative and you add an H to it, you're going to have H2SO4. NH3 and you add an H to it, you're going to have NH4 plus. OH negative and you add an H to it, you're going to get water. And then H2O and you're going to add an H to it, you get H3O plus. So you've seen water behave like an acid and also like a base. That means that water is amphoteric. Okay, like amphibian, it can do both. So water is amphoteric, meaning that it can act as an acid or a base. And I don't remember which video it's in, but it's going to be in one later. We'll talk about it more.